Hi folks, so after working on that PV M2600 and having a pretty easy time of it, I thought I'd go to the other end of the food chain. I got a Crown PSA 2 here. This is labeled as a self-analyzing amplifier. It's not analyzing what the problems are because it's got some real issues. Just to give you an idea, one of the banana posts have broken off on the back, or five-way binding posts as they're properly called. And these LEDs don't seem to be showing what the problems are. I'm able to fire it up on the dim bulb. If you try to put a dummy load on it, the bulb will glow brightly. We've got a real problem in the second channel and no signal passing through the first. So let me show you what I've done so far and what I've found. Okay, so if we fire it up on the dim bulb tester, it does this kind of double thing. Now the fan kicks on, looks okay. But if we look at the front panel, we have some LEDs here. This red LED is for channel 1, and the green one indicates that channel 2 is okay. And this LED indicates that the amplifier is on. However, it's interesting we lost the green one here because I don't think I ever left it in this position long enough to see that. And what I mean is, as soon as I turned it on, I turned it around to look at the back. So if we look at the back here, I'm going to drop the camera so you get a better view. We have a post broken off here. The black or ground terminal is broken off. Fortunately, these are very similar to the ones I bought when I built things for my bench. So shouldn't be a problem to replace them because I've got a set of these and they look virtually identical, if a little cleaner. So I got to replace this, but more importantly, let's step back a little bit so you can see the meter, and I'll show you one of the problems we're having here. So if we look at channel 1, channel 1 looks okay, but channel 2, we got 65 volts, and if we take it off the dim bulb, that goes up to negative 70 some, negative 65, and it'll go up to about negative 70. And if you put a dummy load on this, you'll see a nice big spark, and you'll see the bulb glow brightly and the fan slow down. So we've got a definite problem in channel 2, and channel 1 is not passing any signal. Now, I can hook it up and show you that, but you can take my word for it. So we got a little bit of offset here, but channel 2 has got a real problem. Now, I've never worked on one of these, but I looked at some pictures and it looks like all the output boards are modular, so that may make our job a little easier as far as repair goes. I'm not sure how it's going to help or hinder us during diagnosis. By the way, this is a handy thing to think about, but I couldn't get the screwdriver into the screw here because there's crap in here. I got a set of these inexpensive dental picks from Harbor Freight, and they're really good for just digging out stuff like this so you can get the screwdriver in. Especially with heavy items like this, if you put them onto any kind of soft wood, that'll get in here, and it makes it almost impossible to get the screw out. So you can dig them out with these dental picks. They work really well for this. Okay, so I got the cover off and it's a mite bit dirty. This is one of the issues you find with fan-cooled equipment. It pulls air in, but it also pulls dust and dirt in. And seeing as this is a professional amp, it may have been run in a bar or other environment where they had cigarette smoke. But you can see, if you look right here, how much dust there is, just wads of it. You can see the boards are pretty well coated. We're going to have to clean this baby up a little bit. And gonna have to see what's going on. But the good part is the boards unplug. I don't know which output goes to what, but we'll figure that out, and then we will pull those boards and check them. I've got a bad feeling we're gonna have to be matching up some output transistors. And on Crowns, you match them for voltage between base and emitter. You need to have them closely matched for that, so you won't get what they call current hogging, where one output does more of the work than the others and will therefore shorten the life of the output stage. Okay, so there are 4 screws that go around the modules. You might be able to see these. Somebody's changed these out. These are straight edge screws. The rest of them are Phillips. So I know somebody's been in here. Usually when you get stuff this old, somebody's been in it. It's just what happens when things get to be this old. So I was able to take the screws out and carefully pry up this module. I put a screwdriver through the side here so I could get up here, just gently pry it. There's a connector here, there's a connector here, but the board came out easily. And I believe we have shorted outputs on here. Let me just grab my meter, and you can hear when it sees a short. If we go across the emitter bases, that's shorted. Base to collector, base to emitter. Looks like everything in here is shorted. I haven't gone through the other channels yet, but it's not sounding so hot. Or maybe that's just the way these things are. I'm gonna have to take this apart, clean it up, and take a look at the schematic because I may be missing something. Okay, so I'm back from the dentist, and I thought I'd come out here before the Novocaine wears off and get back to this amp. You can see this board's a lot cleaner. I pulled this board out because I saw some shorts on here. Now, if you remember, I checked some of the other boards, I saw shorts, but that was because I was checking between the base and the emitter. And I'll show you on the schematic why that is. But this one had a shorted transistor here. This transistor was shorted collector to emitter. And once I replaced that, I no longer have the negative 60 or 70 volts on the output that I previously had. So I know that was bad. I don't have the right transistor, but I put one in there just to prove that that was the only problem, and I'm no doubt going to have to order parts. This is an early serial number, and I know there's some modifications, one of which there's a 2.7 ohm 10 watt resistor that needs to go in parallel with the output inductor, so we're probably going to have to do that. But if you look at this thing now, I'm going to show you what the output looks like. Okay, you can see the meter. I'm going to turn this thing back on, and if you recall, the left channel we had about 300 millivolts, 350 millivolts of offset, and now the right channel we also have just about the same thing. Neither channel is passing signal, but I got rid of that horrendous 60 or 70 volt offset. And both channels now look the same. I have a red LED on the front for channel 1 and channel 2. So we're going to take a look at the power supply and see if we have a problem there. Okay, so it's like the PV. We have a lot of op amps in here. I thought it'd be a good idea for us to check our low voltage power supply out and to see what we've got going on. Now, this is kind of a dirty scan, so I'm not sure how well you can see this, but we have our positive 15 and our negative 15 coming out on terminals marked R and Q, with P as our common ground or ground point. Now, some of the lettering is rubbed off on this board, but I looked at one board where it wasn't, and they tend to follow the same convention that we do in the telco industry where I work, and that is that there are no I's or O's because they can be misinterpreted as ones and zeros. Telecom takes it a step further. There are no E's. We just go from D to F. Excuse me. But anyway, it looks like we have a problem here on the negative 15 volt supply, unlike the PV where it was the positive 15 volt. So my common terminal is here at P I'm sorry, that's Q. You can see it's negative 1.6, 1.7, and that is supposed to be negative 15. In terminal R, you can see we have a good solid 15 volts. So we need to take a look and see where our negative 15 volt supply is, because it's not where it's supposed to be. Okay, so I've got this thing on. I looked at the schematic. I had good voltage coming into the regulator, but we had bad voltage coming out. Something's going on with channel 1, by the way. So I just checked the output and just touched this pot, and now we have negative 15 and positive 15. So I'm going to see if we can get a little signal through channel 2. The LEDs look okay on channel 2, but I've got both a yellow and a red on channel 1, and that can't be good. So we're going to see if we can get just a little bit of signal through here. And then I got to see what's going on with channel 1. Let's see here. Now I got to replace the binding, the 5-way binding posts on here, but I should be able to at least get an idea if we got anything at all coming through here. Okay. All right, so this is input 2. Okay, let's flip this on. Hey. Looks like something's happening on channel 2, but I also don't like the frequency. Let me just see. Okay. All right, so we do have signal through channel 2 right now. I still have it on the dim bulb, and something's going on with channel 1, but now at least we have signal through channel 2. So let's see, and like I said, you hear that clicking and the fan slows down. Something's wrong with channel 1. We're gonna have to take a look at that. Okay, folks, finally got to the bottom of the problem with channel 1. Channel 1 had major offset. It would go to negative 50 volts, and then protection would trip in, the voltage would begin to drop, it would drop to a certain point, and then protection would drop out, voltage would go up, and the cycle would continue. This amplifier is a different animal. I'm going to give you an idea here. This is the block diagram. As you can see, we have an NPN output stage and a PNP output stage, and it's kind of a quasi-complementary because all the outputs are NPNs, but the drivers are either NPN or PNP. But that's not where these differences end, because we're going to have to take a look at this. But if you look here, we have our ground coming from the transistors here, and our output is actually coming from the power supplies. This is not your normal configuration, and I'll give you a better idea of that. So if we look here and see, this is normally what you see. You got a positive supply and a negative supply, and the common points tie to ground. And these are our output transistors. This would be the positive side of the output, and it's going to swing either positive or negative as these turn on. Okay, the crown doesn't do that. Crown actually grounds one side of the load here, and the outputs are coming directly off the power supply. The power supply is modulated by our transistors. Took me a little while to wrap my head around it, and I'm not going to lie to you, it's still not wrapped all the way. But I'm not too tightly wrapped. Anyone that knows me knows this is true. So I did finally find a problem with this, and I say this often, but I don't think I say it often enough. Just because these videos are a half hour does not mean it only took me a half hour to find the problem. Okay, I don't edit my mistakes out, but I'm not going to sit and make you watch for hours while I run up blind alleys, make mistakes, try to figure out what's going on. I cut to the chase and I tell you what I found and how I found it. I think this is probably the most efficient way for us to do this. But let me see if I have a good copy of, oh, I think I left it up here. Yeah, so this is a pretty complicated amplifier. I apologize for all the noise here, but I'm running 2 air conditioners, and this thing makes a racket too, plus the test equipment. But anyway, since we have a NPN and a PNP module, we need 2 different drivers, and they're going to be at positive and negative 1.3 volts. And I was having a problem here. My op amps in the front here, the good channel had 0.07 output, the bad channel had negative 12.75. And this was causing our problem. That's why we had such massive offset. Now we're going to trace back from the output to the input. If you look here, this is our positive drive. And it comes off of this dual transistor here, and the negative drive is going to come off of this dual transistor here, and this is what drives the NPN and PNP modules, and they are referenced through this precision divider network into here and here. And our feedback, and I have to trace it from here or I'll get lost again, our feedback comes, I got lost anyway. Feedback comes in from here. So what was the problem? The problem was this op amp. Now a lot of people replace integrated circuits. They're usually pretty dependable, but a lot of times they're replaced because people don't understand what they do in the circuit. In this case, it was bad. So let me show you the board, and we'll talk briefly about the pros and cons of socketed op amps. Well, it was a pro in this case because it made it simple enough to swap this one and this one. Once I did that, I verified that the op amp was actually the problem. I don't have any more of these. These are TL071s. I have 0 TL72s, 74s, no 71s. It's always like this. I dropped in an NE5532. It's a pin for pin compatible op amp, but this is where a lot of people get in trouble. You can't just swap out op amps. There's a lot more to it than pin to pin compatibility. There are people that think you can roll op amps with impunity. You cannot. You drop a faster op amp in there, you're asking for oscillations that you won't hear, all kinds of nasty shit, ultrasonics, ringing. There's a guy who has a great site. He disappeared. Nobody knows where he went, but he was an engineer. He went by NWAV guy. Northwest Audio Video guy. Great site. I'm going to put the link in the description here because his stuff is well worth reading. But cut to the chase, this thing now works. Now I'm going to crank it up on the dim bulb tester. This has a soft start circuit, so it starts out okay. Then the capacitors kick in, and then everything dims down, but it doesn't do that up and down thing because we no longer have the problem we had. So here's our dim bulb, turns on, soft start, and now our LEDs are all extinguished. And even better, if we look at our scope, we got signal on both channels. So I'm going to turn this off and take it off the dim bulb tester. We're going to crank this thing up and see what we get. Incidentally, as I was troubleshooting this, I had both my meters here. I had, I think, a positive 1.3 volts. I only had a negative 0.5 or 0.6. That was the problem. We had in We had asymmetrical drive, and it was causing us a lot of problems. Gonna zoom in here. We're gonna plug this directly in. Okay, so let's turn this thing on. Okay, so now here's our bad channel 1, which is no longer bad, and here's channel 2. So we have good signal out of both channels. Virtually no output because I don't have it turned up enough. If we start ramping it up here, boy, look at that, a whopping 1.1 watt. Okay, well, let's quit messing around. Let's see if we can get some serious output out of this thing. All right, pulling 6.7 amps and putting out, sweet, 232 watts in the right channel. I gotta watch the draw because I'm still going through the variac so I can fix the sags. And it's getting real close. My variac is 10 amp and I'm pulling 7.3. Starting to clip on channel 1 to 240 watts. Our voltage is sagged down to 116. Sagging voltage will cause you to clip at the high end there. Okay. Okay, so yeah, we got pulling 8 amps through my variac. Got a little distortion, but nothing serious. 0.8, 0.1. Yep. Okay, so I'm happy. This thing is working. I still have to fix the banana connector and get the correct op amp. But yep, that was the problem. So we had, to recap, we had a shorted output transistor in channel 2, and we had a bad op amp in channel 1. And this thing's a beast. I don't even know how much it weighs, but it weighs a lot. It's got 2 massive transformers in it. And honestly, it was a different kind of amp to troubleshoot. But anyhow, we shut it off. Everything's working now. Of course, the bias offset, all the adjustments still need to be done. I'm not even going to bother until I get the correct op amp, but the repair is completed. This is the part I always find the most interesting. Why doesn't this thing work? This was a different kind of amplifier for me. It was a great experience to fix. I'm always happiest when I learn something. I'm always happiest after I learn something because the learning process itself can be pretty painful. Anyway, I thank everyone for watching, and as always, I like giving back to the community that's given me so much. Thanks a lot, folks.